between blank and blank, the lower and the upper. Let's say we have two samples, numeric variable, the confidence interval for mu1 minus mu2. This is what we learned earlier today. Okay. X1 bar minus X2 bar. This goes in the center, plus or minus T star times S1 squared over N1 plus S2 squared over N2. Again, estimate for the center, critical value, standard error. They're all in the same form. Degrees of freedom, n minus 1, use the smaller n. And in this case, we'd say I am blank percent confident that the mean of population 1, so that might be the mean height of males, is between blank and blank, more or less if it's negative than the mean of population 2. Population 1 is between blank and blank, more or less if it's negative than the mean of population 2. So that might be, I am 90% confident that the mean height of males is between 4 and 7 inches taller than the mean height of females. Okay, did we get all that down?
Just 1 second.
Okay, no problem. It gets tiring on your writing. Okay, so let's talk about hypothesis tests. Okay, so hypothesis test, we either have one sample and it's categorical, or two samples and it's categorical, or one sample and it's numeric, or it's two samples and it's numeric. all of these, you have to read the problem, and you have to come up with your hypotheses. If we're dealing with a categorical variable, we're dealing with p. So it's going to be p is equal to some number. I'm going to just put 0.4. And then the alternative is that p does not equal 0.4. Okay? But not necessarily 0.4, of course. Okay. Yes?
If these are all under the category hypothesis tests,
Yes.
what was the other one that we just
Confidence intervals.
Thank you.
Okay. If we're dealing with two samples and it's categorical, our null hypothesis is always p1 minus p2 is equal to 0, and the alternative, p1 minus p2 doesn't equal 0, or greater than 0, less than 0, or whatever, okay? The alternative can have not equal, or greater than, or less than, depending on the problem. So read the problem carefully. In these notes that I'm putting here, I'm probably just going to use not equal for all of them. But whether you have something else that's set, okay? Notice there are no hats. Okay, so I'm not putting p hat or anything like that. There's no hats in the hypothesis. Okay, let's talk about numeric ones. Null hypothesis and alternative hypothesis. One sample, numeric. What are we going to put in our null hypothesis? Mu. And if mu is equal to some number, I'm just putting in 15 as a placeholder.
Mu is not equal.
And mu is not equal to 15, or whatever we put.
Mu1 minus.
And for two samples, mu1 minus mu2 equals 0, and the alternative, mu1 minus mu2 doesn't equal 0. Again, it could be not equal, greater than, or less than, depending on your problem. Okay. Your test statistic, okay? So you have your hypotheses, and we have our test statistic. Okay. Test statistic will always be in the form of something we observed minus something we expected divided by the standard error. Or maybe I should say observed minus the null. I should write null. Okay. So here, our test statistic is z is equal to p hat, one sample categorical variable. We have a sample proportion. We subtract off the p in the null hypothesis. That's why there's a p0, divided by the standard error. And the standard error is equal to the square root of p0 times 1 minus p0 divided by n. Okay? p0, again, is the number in your null hypothesis. Is that okay?
Yep.
Two sample categorical variable. Z is going to be p hat 1 minus p hat 2. There might be a minus 0. We don't have to put in a minus 0. Divided by the standard error. The standard error is this ugly thing. P hat times 1 minus p hat times 1 over n1 plus 1 over n2. And what was p hat? P hat is total success divided by total observed. Do you guys remember that from last week?
Yeah.
x1 plus x2 over n1 plus n2. Okay. So that goes in for there. Keep going. Now we're dealing with one sample numeric variable. We're dealing with means. So our t-score is going to be x bar minus mu 0, the mu that appears in our null hypothesis, divided by the standard error. Our standard error in this case, s over the square root of n. Dealing with two samples, x bar 1 minus x bar 2, maybe there's a minus 0, we could put one in if we want to, divided by the standard error. Standard error in this case, s1 squared over n1 plus s2 squared over n2. Okay? Alright, so once we have, so once you have your test statistic, what do? You look up the test statistic in the reference table. Okay? So for categorical variables, use the z table. Okay? And for numeric variables, use the t table. So we have extensively covered the usage of the t-table today, and in the previous weeks you learned how to use the z-table. So from there, find your tail area. And then, if the alternative has a not equal sign, a two-sided test, and the p-value is equal to 2 times the tail area. And if the alternative has greater than or less than, it's a one-sided test, and in that case your p-value is equal to the tail area. That should sound familiar and slightly repetitive. And our conclusions, what are the conclusions that we make?
Its p-value is.
So if the p-value is greater than alpha, your significance level,
Do not reject.
then do not reject the null hypothesis. And if the p-value is less than alpha, then reject the null hypothesis. Is that all right? Okay, so again, this week, do your homework, but also work through as much of the practice final exam as you can. Okay, it's a good practice for the quiz and the final. And we'll go over it. We have a question.
I think you just said if you want to bring the practice exam next week.
Yeah, if you finish the practice final, yeah, do as much as you can and bring a copy next week because we're going to go through it.